In this video, we'll graph these two rational functions. Let's start from A. First, let's find the domain of this function. And we can see for this problem, x could be any real number but -2 because of the denominator. If x is equal to -2, then the denominator equals 0. Right? So the domain is, you can write it this way, x is all real numbers but -2. Or you can write it in the interval notation. You can say it's from -infinity to -2, union from -2 to infinity. Okay, so this is the domain. Next, we want to check if this function g is in lowest terms. Since it's already factored for us, we can see there are no common factors between the numerator and the denominator. So yes, it is in lowest terms. Now let's look at the intercepts. So there will be x-intercept and y-intercept. So to find x-intercept, you want to make y equal to 0. So to make x over x plus 2 squared equal to 0, this fraction is equal to 0 if and only if the top part is equal to 0. So the solution to that is x is equal to 0. So that will be the x-intercept. So our x-intercept is 0, 0. We also need to know the multiplicity of this x-intercept. Since x only appeared once in the numerator, then the multiplicity for this x-intercept is 1, which is odd. We'll use that information to graph this function later. Now let's look for the y-intercept. To find the y-intercept, we need to make x equal to 0. So you will have to find what is g of 0. You will get 0 over 0 plus 2 squared, which is 0. It's pretty obvious because x-intercept is 0, 0. That is, at the same time, also the y-intercept. Right? So the y-intercept is also 0, 0. Next, we want to find the vertical asymptotes. So where do we look at? We look at the denominator. So the 0 of the denominator is -2. So we have x equals -2 as our vertical asymptote. And what is the multiplicity of that? Well, we can see that factor x plus 2 appeared twice, because the exponent is 2, in the denominator. So the multiplicity for this vertical asymptote is 2, which is even. Now let's decide if there is a horizontal or oblique asymptote. So we will have to look at the degree of the numerator and the degree of the denominator. The degree of the numerator polynomial is 1, right? Because the maximum degree of x term is 1. Similarly, the degree of the bottom polynomial is 2. And you can see for the degree at the bottom, x squared is the leading term. Right? If you expand it, you can see it's this. But we only need to see the leading term to decide the degree of the bottom polynomial. Alright, since the degree of the top is less than the degree of the bottom, we say there exists a horizontal asymptote. There is no oblique asymptote. And the equation of the horizontal asymptote is y equals 0. Since we know there is a horizontal asymptote y equals 0, we want to know if our function g will intersect this horizontal asymptote. So we want to know if our function g of x, which is y equals x over x plus 2 squared, and our horizontal asymptote, which is y equals 0, have any points in common. Since y equals 0 is just the x-intercept, this question is equivalent to asking you to find the x-intercept of g, which we already found earlier. It's 0, 0. So yeah, the answer to this is yes, it's 0, 0. Right. I think I've gathered enough information to graph, and for the rest, I will figure them out in the graph. What do we know about the graph so far? We know we have an x-intercept, which is 0, 0, which is also the y-intercept. So for this x-intercept, the multiplicity is odd. Okay, and we have one vertical asymptote, which is x equals negative 2. So it's right here. X equals negative 2, and the multiplicity for that is even. We have a horizontal asymptote y equals 0. I will use a different color so we can see better. So we have a horizontal asymptote y equals 0. Our graph will intersect this horizontal asymptote at 0, 0 also. So also at this point. I need a little bit more information here. So I want to know when x is equal to negative 1, is my graph above this horizontal asymptote or below this horizontal asymptote? So I want to find out what is g of negative 1. Okay, so g of negative 1 is, plug it into the function that's negative 1 over parentheses negative 1 plus 2 squared, which is negative 1 over 1, which is negative 1. So I know negative 1 is a point on the graph. Okay, so negative 1 is right here. This point is on the graph. All right, so I think I can begin. All right, so first of all, I will have to connect this negative 1 and negative 1 with our x-intercept, right? Well, since the multiplicity for this x-intercept is odd, that means our graph will pass this x-intercept. So we'll go through this x-intercept. But here, since y equals 0 is the horizontal asymptote, your graph will get closer and closer to y equals 0 as x goes to infinity. Okay, so that's the right side of the graph. Okay, now let's go back to negative 1, negative 1. Since we only have one x-intercept, our graph can't go up and pass the x-axis anymore. So the graph has to go down from here, all the way down. Okay, since the x equals 2, this vertical asymptote has even multiplicity. That means on both sides of this vertical asymptote, the graph will go to the same side. So since on the right side is going down, on the left side it's going down also because of the even multiplicity of the vertical asymptote. All right, and since our graph won't pass y equals 0 anymore, but it will also get closer and closer to it as x goes to negative infinity, this is how our graph will look like. And in the next video, we'll graph b, the function r.